Hello, my name is Ian Clark, and this is my application for the TF position. Starting with prompt 1. If a student asks me a question to which I don't know the answer, I would respond honestly and transparently. I acknowledge that while I may not have the immediate answer, I'd reassure the student that we explore it together. To begin, I would utilize any resource available to me, such as the course portal and instructor slides, and I try to find any information that could help the student. I would also encourage other students in the breakout room to contribute their insights and perspectives, which could help foster a collective learning experience. Essentially, I believe that the most important part in this process is to work together to make sure that everyone's questions get answered. Moving on to prompt 2. If I find myself in a breakout room with all the cameras off and minimal participation, I'd first try to initiate a discussion by asking an open-ended question related to the topic at hand. By starting with a question that invites reflections or opinions, I aim to stimulate engagement and encourage students to share their thoughts. If there's still not a lot of participation, I praise the input of those who did participate and ask follow-up questions so I can delve deeper into their ideas. Additionally, I periodically summarize any key points that were raised by participants so I can maintain focus and encourage active listening among the group. I wouldn't ask anyone to turn their cameras on because I understand that not everyone has their own reasons for keeping their cameras off. And from personal experience, I've noticed that if the discussion is going well, people will naturally be inclined to turn their cameras on. Moving on to prompt 3. Okay, let me share my screen. Okay, so let's break down how we can use the binary search algorithm to find an item in a sorted array. I have some code in Python to help demonstrate. So first, let's take a look at this sorted array. It is indexed index 0 through 9, 10 elements. And let's say our target number is 23, and we want to find its respective index. So in this case, it would be index 5. So the binary search approach starts with defining a left and right variable, where left represents the leftmost index in the array, which would be index 0, and right represents the rightmost index in the array, which would be index 9. We would calculate the middle index of the array by adding left and right and dividing it by 2. So in this instance, it would be 4.5, 0 plus 9 divided by 2. But we can't have an index 4.5, so we would actually round down to index 4. So our middle index would be index 4, which is associated with the element with the value 16. Moving on, we compare the middle element of the array with our target number over here in this if statement. So basically, what this is if the element associated with the middle index is equal to our target number, which once again is 23, return that middle index. Right now, our middle index is 4, and the number associated with it is 16. 16 is not equal to 23, so we move on to our second if statement. If the middle element is less than the target, we would update the left variable to mid plus 1 and repeat the process in the right half of the array. So the element associated with our middle index 4, 16, is less than the target, 23. So what we would do here is make our left variable equal to mid plus 1. So left changes from 0 to 4 plus 1, which is 5. So our left variable is now 5. And going over this next else statement, this basically says if the middle element is greater than the target number, then we would update the right pointer or the right variable to mid minus 1 and repeat the whole process in the left half of the array, essentially doing the opposite of the second if statement. So let's test our binary search function with the target number 23. This code right here. And we see that the target number 23 is found at index 5. So going over the code, starting off at 4, and going back to this else if statement, the value associated at index 4, 16, is less than 23. So left becomes 4 plus 1, also known as 5. And looping back, if array mid equals target, which is now mid equals is now 5. So the element at index 5, aka 23, is equal to target. 23 is 23. Yes, so we return mid, we're returning 5. So we managed to do that in only one loop, and we were able to find the index associated with our target number. So that's just a quick overview of how binary search works.